Today I'm going to take you through how to do a limiting reactant calculation. And if you haven't already downloaded the lesson sheet, then you can just write the example out and go through it as I go through it. So let's take a look at what the question is asking. When copper 2 chloride reacts with sodium nitrate, copper 2 nitrate and sodium chloride are formed. Step 1, write the balanced equation for this reaction. So we've got CuCl2 plus NaNO3 for sodium nitrate yields copper 2 nitrate. And again, this is where all of our formula writing comes into play, plus sodium chloride. I must balance that. 1 copper, 1 copper, 1 sodium, 2 chlorine. So I must put a 2 here. That affects my number of sodiums, 2 sodiums, put a 2 here, and that yields 2 nitrogens. I've got 2 here, 6 oxygens, everything is balanced. Now, we're going to essentially be doing a mass calculation twice, because with limiting reactant calculations, they give you the mass of both reactants, and they want you to figure out how much of a certain product can be formed. So in this case, they tell you that you have 15.0 grams of copper 2 chloride. So this is given, and I use little m for mass. And the mass is given to us in 3 significant digits, 15.0. And they also give us the mass of sodium nitrate. I tend to put the formula beside the symbol for m so I know what mass that corresponds to. And they want you to figure out how much of this product you can make. In a mass problem, you would have only been given one mass of a reactant and an excess amount of the other one. Well, in this case, we don't know which one is an excess, and so we have to figure out which reactant will run out first. And we know that when that reactant runs out first, then we have come to a complete stop of the reaction, and that is the maximum amount of product that we can make at that point once the reactant runs out. So what I do is I tend to split up my page, and I do essentially a mass problem for each reactant on either side. So I'm going to let this side be my copper 2 chloride, and over here I'm going to let this side be my sodium nitrate. The first step of a mass problem was to come up with a balanced equation. The second step is to take the mass that's given and convert that into moles. So I'm going to take the 15.0 grams of copper 2 chloride, and I want to know how many moles that's equal to. Well, when you go from mass to moles, you must take mass divided by molar mass. And what I did was I already looked up the molar mass of copper 2 chloride, and it's 134.45 grams. When I put that into my calculator, I end up getting 0.111565637. Now, I do not want to do any rounding at this point because I'm still in the middle of my calculation. I'm going to do the same thing on this side. I'm going to take the mass that was given for sodium nitrate, and I'm going to figure out how many moles that's equal to. 20.0 grams. The molar mass of sodium nitrate is 85 grams per mole. Notice that my grams cancel out. And on my calculator, I get 0.235294117 moles. The next step in our calculation when doing a mass was to set up a mole ratio. So what I want to do is I want to set up my ratio with the product that I'm looking to solve for, and that happens to be sodium chloride. So on this side, my ratio will be with this reactant, copper 2 chloride and sodium chloride. According to the balanced equation, this is a 1:2 ratio. For every one of these that reacts, for every 1 mole, you get 2 moles of sodium chloride. However, I do not have 1 mole of copper 2 chloride. I only have 0.111565637 moles. So I'm going to set up a cross multiplying. And when I do that, I solve for x, and x will equal 2 times this value, which is 0.223131.275, and that would be moles of sodium chloride. We're going to do the same thing on this side. We're going to set up a ratio with sodium nitrate. So sodium nitrate to sodium chloride, based on the balanced equation, we have a 2:2 ratio, meaning for every 2 moles of sodium nitrate that react, you get 2 moles of sodium chloride that are formed. That is also the same as saying 1:1 because it is the same coefficient. So if it is a 1:1 ratio, or 2:2, or 3:3, or 4:4, whatever mole value you had, it will be the same quantity because it's the same ratio. Okay, but if you need to, you can set that up, and your x equals 0.235294117 moles of sodium chloride. So now what we do is we take a look and we say, okay, well, I have 2 mole values for sodium chloride. Which one am I going to pick? Well, in this case, you take a look, whatever one yields the smaller mole ratio value is the one that you must go with, because this means that copper 2 chloride is going to run out first, and this is the maximum amount of sodium chloride that you can make. So we do not pick this one, we must pick this one here. So going back up, I can now say that because this one yielded the smaller amount of product, this happens to be my limiting reactant, and this one is my excess reactant, meaning that there will be some of this left over, okay? Now, what I do is I can now proceed with step 4, but I only need to do it for this reactant. And what I'm going to do is I'm going to figure out what mass of sodium chloride that equals. So to figure out the mass of sodium chloride, what you must know is the moles of sodium chloride times the molar mass of sodium chloride. I know that this is the mole value that I'm going to use, and I would have to look up the molar mass of sodium chloride. And again, I'm not doing any rounding at this point. Now, the molar mass for sodium chloride is 58.44 grams per mole. I do not use this coefficient as part of my molar mass, right? Remember, coefficients we only use when we are setting up our mole ratios. They do not take part in the calculating of molar mass. So I see that my moles cancel out, and this is where I'm going to keep my final answer now to 3 significant digits. And why have I chosen that? Because the original masses that were given are in 3 significant digits. So 13.0 grams. I'm not going to just write 13. I'm going to write down 13.0. So this happens to be, and I'm just going to put a nice big box, that is the theoretical yield of sodium chloride. The limiting reactant, or reagent, we can call it, in this reaction is copper 2 chloride. Okay, and we know that that is how much sodium chloride we can make given the above masses.
Now that we've established which of our reactants is the limiting reactant and our theoretical yield, let's talk about how to determine how much of the excess reactant you have left over. This is really a 3-step process. The first thing that you want to do is figure out how much of the excess reactant actually reacted. Step 1, you'll want to set up a mole ratio between the limiting reactant and the excess reactant. So in this case, between copper 2 chloride and sodium nitrate. According to the balanced equation, they react in a 1-to-2 ratio. So what I do is I set up a ratio between those two, 1-to-2. We know that all of the limiting reactant gets used up. So how much of that did I have to begin with? Remember up here, we took 15 grams divided by the molar mass of copper 2 chloride, and that told us how many moles we had. We know that this is the limiting reactant, so all of it gets used up. On the bottom, we are going to let X represent how many moles of sodium nitrate reacted. So when I do a simple little cross multiplying, we see that we get 0.2231311274 moles. And yes, I kept all digits at this point in time. So this is how many moles of your excess reactant actually reacted. We want to figure out how many moles are left over. So what I do is I go back to the original mole value that I calculated for sodium nitrate. This is how many moles I had to begin with. And what I do is I end up subtracting how many moles I had to begin with. I subtract how many moles reacted, and I get how many moles of sodium nitrate are actually left over. Then I want to convert that back into a mass. So I take that mole value, and I know that moles of sodium nitrate times molar mass of sodium nitrate, which I already had from up here, multiplied together, that indicates that I have 1.04 grams of this particular reactant left over. And that makes sense because if you get a value that's greater than what you started off with, that would not be valid. So it is plausible, because you started off with 20 grams of sodium nitrate, that you can in fact have 1.04 grams left over. In the last part of this question, what they're asking us to do is to calculate the percent yield for a reaction. They give you 11.3 grams of sodium chloride is formed in the reaction. So that's your experimental value, or considered your actual value. And what is the percent? So recall that in order to calculate percent yield, you need to have the actual yield, which is your experimental value, all over your theoretical yield. And the theoretical yield we determined was 13 grams. What you'll do is you'll take that value of 11.3 divided by 13 multiplied by 100, and that gives you an 86.9% yield. And again, I kept my answer to 3 significant digits based on the original masses that were given were in 3 sig fig.